Hey guys, how's everything going? This is JSer, who's not good at algorithms. In this video, I'm going to take a look at the 1-to-1 best time to buy and sell stock, which is the easy one. Okay, we have an array at which ith element is the price of a given stock on die I. We were only permitted to complete at most one transaction, buy one and sell one. This is an algorithm to find the maximum profit. Design you cannot sell stock before you buy one, so their order is matters. Well, we need to return the profit. So for example like this, we buy on 1 and sell on 6. So it's 5. Well, obviously we need to buy. We need to buy at minimum, sell at max, right? Which means max is after min. So let's suppose we buy at 7. Where do we sell? Well, if we buy at 7, we need to sell at 6, right? So we need to find the maximum of the rest. If we do it, and then we buy at 1, we need to sell at 6, right? Still 6. But we need to search for the rest. So if we to buy at I, search sell at j cost n minus I, right? So actually, yeah, so you know the time would be square. Could we improve that? You see, we already noticed that if we start at 7, we sell at 6. And we start at 1, it's still at 6. We don't need to actually search 1/6 biggest in this, because the largest number in this would actually be the largest number in this one, right? Yeah. So if we take a look at this problem backward, if we say first we buy at 4 and sell at 4 is 0, right? Then go to 6, and then go to 6. We already get to the maximum. It's 4, right? Get the maximum 4. The previous maximum is 4, so we can only do one comparison with this 6 to get the maximum of 4, 6, right? So buy at 6, we sell at 6. And buy at 3, because the maximum here is 6, and it's bigger than 3, so we don't need to change the maximum. So it's still buy at 6 of 3, sell at 6. Buy 4, 5, sell at 6. Buy 1, sell at 6. Buy 7, sell at 6. So if we take once again reverse it, we could take at the sell position, right? If we go to sell at 0, we need to buy at 0, right? Because no one is smaller than 7. But now if you're going to sell at 1, the 1 is smaller than 7, we must buy at 1. But now we sell at 5, we need to buy 1, because 5 is bigger than the minimum, which is 1. So this reminds us we could do loop through the price, keep track of the minimum, get profit at each index, and collect the max, right? So it's pretty clear. Let's do that. Net mean price for the first, what could we set to the first one? Price is 0. Okay, for we don't need care about the index, I think. So for let price of prices, if price is smaller than mean price, we update mean price equals price, right? So best profit selling at this price would be cost profit would be price equals minus mean price, and we need to update the max, right? Let max profit Use camel case here. Zero. It shouldn't be. There might be a case amount of negative numbers, so we set it here. Profit would be math max 0. So if profit is bigger than max profit, okay, max profit equals math max profit. Pretty clear, right? Pretty profit, max profit. It's pretty clear. Now we need to return the max profit. Let's run the code. Cool. Submit. Yeah, we're accepted. Okay, we actually have a follow-up, like next challenges. I will do it in another video. Yeah, I hope it helps. So the lesson we learned from this problem is when we're doing anything about array problem, we analyze the basic format, like start from the first index and to see what we are going to do. And you see, we always could find some duplicate work, like finding the maximum of subarray. Then we try to eliminate that duplicate work by thinking the forward or backward or caching some min-max. And the best thing, one more advice is to think of the problem which not start from some point but end at some point, right? For here, we'll say we buy at specific index, and then we need to collect, if we from the original direction, we need to find the max. But if we think of, say, okay, we sell at specific index, like sales at 5, you will like for human, maybe it will be more natural to realize that we could cache the minimum, right? Cache the minimum and do it in one pass. So yeah, analyze the examples more and get the best result. Cool, that's all for this one. And though it's easy, don't forget to follow my channel. See you next time. Bye bye.